In this video, I'll be going through the June 2022 Paper 2 Higher. Let's make a start. Question 1, we've got some inequalities. When you multiply inequalities, you just times them together. So that's going to be x to the power of 3 times 5, which is 15. The next one, expand and simplify. So if we work from left to right, that's going to be 4x plus 12 plus 28 minus 14x. If we now collect the like terms together, that's going to be that and that, which gives us 40. And then that and that, which gives us minus 10x. So fully factorized, we can see that 3 is common in both, so we can factor the 3 out. And then they both have an x, so we can take out an x squared. So that leaves us with 15x cubed plus 3x squared, and we just need a y there. So that's that. Question 2, describe fully the single transformation. So we can see that it's been translated. So there has been a translation by, so we're going to have a column vector. So it's going to, so if you use one point, let's say, just use a different color. If I pick that point, I'm going to map that to the same place here. So I'm going to move 1, 2, 3, 4, 5 to the left. So that's minus 5. And I'm going to move 1, 2, 3, 4, 5, 6. 6 up. So that's going to be minus 5, 6. Question 3. So we've got a length of a football pitch is 90 to the nearest meter. So that's going to be 89.5 and 90.5. So that will round up to 90 to the nearest meter. And that will become 92 because it's not equal to here. So bear that in mind. So 4, we have a festival with an area. We also have another festival with an area, and it's asking us which one has more area per person. So we need to work out the area per person for both. So for A, it's told us 80,000 is the area for 425 people, which then means one person. We're going to divide each side by 425. It's going to equal to 188.24. And for B, it hasn't given us the area, but we know the field is 700 by 2000. So we're going to multiply the two together, 700 times 2000, and that gives us 1.4 million. That's going to have 5 zeros. It's equal to 6750 people. Divide each side by 6750 to work out how much area one person has, and that comes out to 207.41. And now it wants to know how much more area people have in B than A, so that's going to be 207.41 take away 188.24, and that gives us 19. So Callum says 300 centimeters cubed is the same as 3 meters cubed because there are 100 centimeters in 1 meter. So that is correct. 1 meter is equal to 100 centimeters. So to go from 1 meter to centimeters, you times by 100. However, to go from 1 meter squared to centimeter squared, we times it by not just 100, but we times it by 100 twice. So that then ends up with 10,000 centimeters squared. So in his case, 3 meters, though, because area is times, and you can just write times 10,000, or, and then you can also write that 3 meters squared is equal to not 300, but 340 centimeters squared. So 5, we've got some points that lie on a line. Right, so we've been given a ratio. Cool, so if we plot this on a graph, just so we can get a rough idea of what this looks like. So if I plot L, that's minus 3, 1. So minus 3, 1. Let's plot that point there. The next one is M at 4, 9. So let's put 4 there. And 9 will be roughly there. So that point's there. So that's going to be L. That's going to be M. And then N is going to be, somewhere down here, because we are told it's a straight line, but we don't know where. So the way we do this is, well, how do you go from L to M if I actually draw a line between connecting these two as well first? Right, so to go from L to M, we go across from minus 3 to 4, so we go across by 7, and then we go up from 1 to 9, so we go up by 8. So now we're told L to M n to n is a ratio 2 to 3. So here, if I go across by 7, that means to go from m to n, I'm going to go across by, times it by 1.5. So if I times 7 by 1.5, it means I'm going to go across by 10.5. And then I'm going to go up by 8 times 1.5, which is going to be 12. So I times this by 1.5 and this by 1.5. And that showed me how to get from m to n. So I know the points at m are 4, 9. And from what we've just calculated, we're going to add 10.5 to the x-axis. So that's 14.5. And we're going to add 12 to the y-axis. So that's 21. And those are the coordinates of n. So we have a new phone here. It depreciates by 4% every year for 3 years. So percentage is out of 100%. It depreciates by 4%, which gives us 96%. As a decimal, that's 0.96. So we're going to do 679 times 0.96 to the power of 3 because it's 3 years. And that gives us 674 pence. Question 7. So we are comparing the price of fuel in Spain and Wales. What you need to be careful of here is the units. So in one place it's using euros, in one place it's using pounds, and also it's using litres and gallons. We want to use consistent units to draw a comparison. So we have Spain and we have Wales. So first we'll write down what we have been given. So we have been given, so if I write euros, so that's 27 euros is 18 litres. And on this side we're told that £40 and 80 pence is equal to 8 gallons. Now, we want to use consistent units. So for price, I'm going to use pounds. And for volume, I'm going to use litres. So on the left, we're going to convert 27 euros. So 27 euros to pounds. I'm going to times that by 0.85. And that's going to become £22 and 95 pence. So I can rewrite this as £22 and 95 pence is equal to 18 litres. And now I'm going to find out how much 1 litre cost. So I'm going to divide each side by 18. And divide the left by 18 too. So 1 litre costs £1.28. And on the right, we already have pounds, but we've got gallons. So I'm going to convert the 8 gallons. So I'm going to convert the 8 gallons to litres, and I'm going to times that by 4.5, and that becomes 36 litres. So for £40 and 80 pence, you get 36 litres. I'm going to divide each side by 36 to find out how much 1 litre cost. 1 litre here costs £1.13. So now you can compare this, and you can see what's cheaper. Wales is cheaper, so is Sam right? No, Sam is not right, because Sam thinks Spain is cheaper, so we would write no. We just use the same colour that we've been using, so no, Sam is not right. And then you just write a statement that says petrol in Wales is £1.13 per litre. In Spain, it's more expensive at £1.28 per litre. So question 9, use your calculator to work this out. So if you type these numbers into your calculator, hit enter and round that to 3 significant figures, you're left 0.739. So question 9, we have a pressure, force, area question. So in this question, we have been given the formula on the top right. So we have the force given at 180 newtons. We have the pressure also given at 187.5 newton per meter squared. Now, we haven't been given the area. We can calculate that, but specifically this question's asking us to find the width. It's a cuboid. So a cuboid would have a square face, which would have a width and a height, or width and a length in this case. So just to quickly sketch that on here, cuboid looks something like this, and we're looking at essentially the face that's being pressed down, and the face would just look like a triangle, which would have a length and a width. So from this, we can work out the area. So we can rearrange pressure is equal to force over area. as area is force over pressure. So area is equal to 180 divided by 187.5, which gives us 0.96 meters squared as area. But I know for area, it's going to be length times width is equal to 0.96. The question gives us the length at 1.2, and we just need to figure out the width. So if I rearrange this, divide each side by 1.2, I end up with the width equal to 0.8 meters. Moving on to question 10, we have a box plot. So it says Andrew says 3/4 of the data lie between 160,000 and 350,000 because these values are the lower and upper quartile. So that is the lower quartile, as Andrew has pointed. That is the upper quartile. So the upper quartile represents 3/4. The lower quartile will represent 1/4 of the data. So if you do 3/4, take away 1/4, that means the interquartile range represents half the data. So Andrew is long because it represents, so we would just write the fact that it represents 50% of 3/4 of the data. Yeah. So he's saying 3/4 of the given data lie. It's not 3/4, it's actually 50%. So moving on to the next one, it's asking us to plot the box plot with this. So each square goes up by 10. If I go to 30, that's going to be here. If I just use that. 3, that's 30. The next one is 80 for the lower quartile. So that's going to be there. The next one is the median at 170. The next one is the upper quartile at 260. And finally, we have at 350 the greatest value. And if I just connect this box together, just like the one above, of course, using a ruler and a pencil in the exam. And now it's asking us to compare the distribution of online versus the shop. So to compare the distribution, you normally want to compare two things. So that it's usually the median and the interquartile range in order to get the marks. So the first comparison would be the median. So the median here is given at 170. The median up here is that value there, which is 200. So you can first compare the median. So you can see the online median is greater than the in-store. I'm not going to write this all out, but you would compare the median online 200 and in-store is 170. Yep. So median online 200 and in-store there. And then you just say the median online is greater, or median online is greater at 200 than in store, and then you do the same for the interquartile range. So with the interquartile range, you'll have to work out the interquartile range. So up here, it's going to be 350 take away 200, 160, and then down here, it's going to be the lower quartile take away the upper quartile, which then gives you 180, so that it's a difference of 10, and then you would compare the interquartile range is greater online, which is 190, than in store, which is 180. Moving on to question 11, so we have 13 workers. He has access to 13 workers, but we know that 6 workers take 14.5 days. And then we just need to prove that the job can be done in less than 7 days. So he's got access to 13. So 13 workers. Now just careful here, this side does increase, so we times it by 13 over 6. Now this side, we're going to divide it by 13 over 6, because if there's more workers, it's going to take less time. So you get your answer as roughly 6.69 days. And that's proof that it'll of course be done in less than 7 days. And then we have 2 equations here. It's saying show that these 2 lines are parallel. So parallel lines have the same gradient, so we can start by writing that. So parallel lines have the same gradient. So we have line L1 where y is equal to 2x plus 3. So here, gradient is 2. And then we have line L2, which we have to rearrange. So if I keep the y on the left, move everything else over, that's 10x plus 4. If I divide each side by 5 to make y the subject, that's going to be 2x plus 4 over 5. And that is going to be minus. Just careful with the signs there. And then again, you've got the gradient at 2. So since they both have the same gradient, they must be parallel. Now, in large to shape by a scale factor of -2 around the center 0, 0. So the center is there. So if you start off with each point, so if I start off with this point up here, if I move 1, 2, 3, so I've gone 3 across, 1, 2 up. So that means I'm going to multiply it by 3. So it's going to go 1, 2, 3, 4, 5, 6 across. And it's going to go 4 up, 1, 2, 3, 4. So there's that point there. Now you're going to carry on in similar fashion, but you should be able to tell by just looking at that the next point is going to be somewhere there, because the width is going to increase from 2 to 4. So that's that. And then you can carry on in similar fashion with the rest. So I'm just going to rub this off so it doesn't look too confusing. And then you do the same with this point. So it goes 1, 2 across, and it goes 1, 2, 3, 4 up. So we're going to go 4 across. So that's going to be 1, 2, 3, 4. And then we're going to go 4 times 2 up, which is 1, 2, 3, 4, 5, 6, 7, 8. So that point is going to end up there. And finally, you do the same for this last point here, but we can figure that one out just by looking at that. So that's going to end up somewhere there. And if I connect the points together, you would end up with a shape that looks like this. Question 14. So he wants to work out the number of fish. He tags some on Friday and he puts them in the lake. Then he takes them back out on Saturday. So on Friday, we know he's tagged 180 tagged. And then we know on Saturday he takes them out. He catches 305 of these. 45 are tagged. So we know in total how many are tagged, 180. How do you go from 45 to 180? Times it by 4. So that means in total there must be 4 times 305, which is 1220. So 15, the ratio of Maria's hourly pay to Khalid's hourly pay is 65. So it's a 6-to-5 ratio before the increase, and then after the increase it goes up to 13-to-11. So we just know the ratio of the hourly pay. We don't actually know what the hourly pay is at this point, and we know it's been increased by £1.50, so we can write this as 6x, because we don't know what the exact amount is, plus £1.50. So if we just focus on this bit here, how do we get the probability? So it's normally going to be written as 6 over 11, so 6 over the total. So in this case, it's going to be 6x plus 1.5 over 6x plus 1.5 plus 5x plus 1.5. And if you total that up, that will equal to 13 over 24, which comes from here, because we've been told that. So if you tidy that up a bit, that's 6x plus 1.5 all over 11x plus 3 is equal to 13 over 24. And if you just rearrange that and tidy it up a bit, so that's going to be 6x plus 1.5 times 24 is equal to 13 bracket 11x plus 3, which becomes 144x plus 36 is equal to 143x plus 39. And then if you tidy that up, this will go and you'll be left with just 1 here. So that'll be x is equal to 3, because you can take away the 36 from each side. So now that we know that x is equal to 3, so essentially we had the ratio 6x to 5x, and 6 times 3 is 18, and 6 times 5 is 15. Sorry, not 6 times 5, 3 times 5. So 16, we have a manager who wants to advertise offers on his platform. He asks 100 customers which platform they like. So we know 4 use all 3, so that's going to be right in the middle. So we'll tick that off. 16 do not use any, so that'll be outside. We have 8 that use both type A and B but not C. So they use A and B but not C. So that's going to go in there. And then we have 14 that use both B and C. So that's going to be 10. Now, I'll explain why this is 10 and not 14, because this is different to this statement. Now, this statement here said but not C. So we put the 8 in here as it is. But here it does not say but not A. If it said but not A, we would put 14 in here. But because it said B and C, we also have to take this value into account, because we're looking at this bit here. Because it said B and C, it can fall anywhere in this region. We already have a 4 in there, so then this must be 10. And then we're left with 62 use type A. Okay, and then all 20 who use C also use at least one of A or B. So that means there's nothing within this bit here, because it says all 20 use at least one of A or B. So that means that this must be 10, because C has 20 altogether, and all of the users use either A or B. Okay, so that one is done as well. And now we know that A adds up to 62. So at the moment we have 10 plus 8 plus 4, which is 20. And if you do 20, take away, which is not 20, sorry, it's 22. And then if you do 22 minus 62, that gives you 44 here. And then if you add all of this up, it doesn't quite add up to 100 yet. Because remember, it all has to add up to that 100. Because we know C has 20. That's done. We know that A has 62, as the question tells us. So that's that done. And then we're left with add all of these up, including the 16. Take away from 100. And we're left with 12 in there. Now, for part B, it says the bit you want to be careful of is, given that the customer is type A, because we're given that, it's going to be out of 62, because he is type A. Find the probability that the customer also uses type B. So the probability that they use A, so if I just get my pen out, A is 62. The fact that they also use B can be any value within this bit, so it could be that or that. So that's going to be 8 plus 4, which is 12. Now, question 17, we have a sphere and we have a cone, and it's asking us to find the total height y. So this height can really be split in 2 bits. Now, this bottom bit here is going to be 3.5, because I can tell that by the radius of the cone without doing any work. And this top bit here really is the missing height h for the sphere that we need. And we've been told what the total volume is. So because we know what the total volume is, we want to find the volume of the cone, the volume of the sphere, and somewhere in there we'll also find the height that we need, so that we have the sphere and then we have the cone. So for the sphere, we have the volume given at, now bear in mind it's going to be half. We've only got half of a sphere, so it's going to be half of the formula they've given us. So that's going to be 1/2 times 4/3 pi. R cubed is going to be 3.5 cubed, and that gives us 90 here. Now with the cone, we have volume is 1/3 pi r squared h, so that's going to be 1/3 pi r squared h. We don't know what h is, that's what we're trying to find, so that can be written as 49/12 pi h. Now we know the total volume is 120, so we know that the sphere, which is 90, plus the cone, which is 49/12 pi h, is equal to 120 pi. Now if you rearrange this for h, you will get h out at 22.37. Now that's not the answer. Remember, the question is asking for the value of y. Y is this whole length. H is just that bit there. So we're going to add h to 3.5, and your answer becomes 25.9. Now the next bit's saying that the volume remains the same, but they've increased the diameter. So if you look at, for example, the cone formula, so this stays the same. They've increased the radius. So in order for the volume to remain the same, the height must decrease. So, and you can also type in a few numbers in your calculator and see what happens when you increase the radius in order to keep the volume the same. So the height y decreases. So question 18, calculate QS. So with this, you should straight away start thinking about sine rule and cosine rule, but essentially they're asking us to find what this is. Now, in order for me to find this, I can use the sine rule between this and this and this and this, but I need to know what this is first. So I'm going to start by finding out what this is. And in order to find this, I'm going to use the cosine rule. So if I just label the side, so this will be lowercase q, this can be p, and this can be r because it's opposite r. So if I write out my formula for cosine rule, that's p squared is equal to r squared plus q squared minus 2rq cos p. And then we have 11 squared plus 9.4 squared minus 2, 11, 9.4 cos 27. And then if you type that all into your calculator, you get p squared. So I'm just going to write that here as well, actually, because it is p squared at the minute, 25.0998. And you get p at 5.00. You can just say 5. So now we know what p is. I can use that to find QS, because now I can use the sine rule. So since I'm finding a side, I'm going to write a side on the top, so that's going to be 5 over sine 41. So remember, that comes back to this and this linked together, this and this linked together, and then I can find what this is. And that is equal to QS, what the question is asking for, over sine 88. And if you rearrange that, you get QS to 3 significant figures as 7.363 centimeters. And with question 19, we just need to substitute 16 into this. So that is going to become g of 16 is equal to cube root 2, 16. I don't need this bracket, minus 5, which is just a cube root of 27, which is 3. So the next one's slightly trickier because we need to find the inverse of g of x and substitute that into h. So if you write out g of x, cube root 2x minus 5. Now we're going to replace g of x with y. Everything else remains the same. And now we're going to swap the x and the y. So we're literally just going to swap that and that as it is. So that's going to be x is equal to cube root 2y minus 5. And now I'm going to rearrange this for y. So that's going to become cube on each side. So that's x cubed is equal to 2y minus 5. So that's x cubed minus 5 over 2 is equal to y. And that is essentially the inverse. So this essentially becomes g minus 1x is equal to x cubed minus 5 over 2. And now if you look back at the question, all we need to do is put it into h. So if you look at h up here, I need to put into here what I've just found. So that's going to become h g minus 1x is equal to 1 over what I just found, which is x cubed minus 5 over 2. And I can write this as 2 over x cubed minus 5. Question 20, so we have been given a circle, work out the size of CDE. So that is asking me to work out what this is. So straight away, using some circle theorem logic, we just start with deducing what you can. Don't worry too much about exactly how you're going to get to CDE. What can you figure out? So just by looking at this, I know that's going to be 66 because angle at the center is twice the angle at the circumference. So I can use the 132. So the way I got that is I did 132 divided by 2. That 132 came from there. Just going to rub that line off. But just by looking at the shape, what else can I figure out? That angle there, that is going to be 180, take away 66, which is 114. How did I figure that out? Because opposite angle in a cyclical quadrilateral, so this and this are going to add up to 180. And what is a cyclic quadrilateral? Is a quadrilateral where all 4 of its points lie on the circumference. So that's this point, this point, this point, and this point. They all lie on the circumference. So it's a cyclical quadrilateral. Now I know what that is. I can figure out what this is. So this is just going to be 180 take away 66 because angles on a straight line add up to 180. So I know that this is 66. Now that I know that is 66, I can figure out what this is, because angles in a triangle add up to 180. So that's going to be 180, take away 66 plus 16, and that gives you 32. So of course you'd have to write all this out, because in questions like this you are given marks for reasoning. So we will start with something like BAD is the first thing we figured out, is equal to 66 degrees, and you would write that angle at center is twice the angle at circumference. And then you have BCD. That's the next thing we calculated, and that came out as 114. And my working out's all up there anyway, so I don't need to go too much into working out here. I just need to explain why it is. So in this case, it was opposite angles in a cyclical quadrilateral. And then DC and E, 66 degrees, because angles on a straight line add up to 180. And then finally, what the question asked for, which was C, D, and E. I got that at 98 degrees. Yeah, sorry, just realized I made a typo there. So that would be 98 degrees, and that is because angles in a triangle add up to 180 degrees. So 21, it's asking us to sketch y is equal to f of minus x. So we're just going to reflect it in the x-axis. So that point goes there. This point here ends up, so it's 1, 2, 3 from this side. So it'll be 1, 2, 3, it'll end up there. And then this one here will be 1, 2, 3, 4, 5. So it's 1, 2, 3, 4, 5. It'll end up right there. And then finally at the bottom, that point will end up there. So it'll be as smooth as you can. It'll need to be as similar to the ones on the left. So there we go. A reflection there. So we have been given a tan graph, and we know that Q has been moved from there. So it ends up on a coordinate of 90 minus 5. So first things first, bear in mind that this is 0, as shown. This is 90. This is 180 here. This is 270, goes up by 90 each time, and this is 360. So essentially what's happened is Q is here right now, and it's been moved to the left, and it's now here. So that's the first thing to bear in mind. So the expression by default was G of X. So what's now happened is we've moved to the left, so we're going to add. So this is a little bit tricky because people normally think left is negative, but in this case we've moved to the left by 270. So we've moved from 360 to 290 because it's told us right here. It's told us we've moved to a point on the x-axis that's 90. So it's moved to the left by 270. However, it's also moved in the y-axis. So it used to be at 0, and now it sits here, but then somewhere there. So that's where the new point sits. I should probably mark that on as well. So the new point basically sits somewhere there, and I should label that R. It's also moved up. So in this case, because it's moved up, it's going to be a negative 5. Sorry, it's not moved up. It's moved down. It's a negative 5. So it's going to be there as R. So when you're moving up and down, it's the usual. So up is positive, down is negative. But when you're moving right and left, in this case, right is negative and left is positive. So find algebraically a set of values for x, which, okay, these are both true. So if I start with the left, x squared, if I add 49 to both sides, I get that. If I square root both sides, I get x is greater than plus minus 7. So I can write this as it's between -7 and 7. And you can also check this on your calculator. If you put 7 in there, you get 49, so it can't be equal to. But if you put 8 in there, you get 64. Is 64 greater than 49? That's true. But if you put something like, say, 3 in there, now 3 squared is 9. Is 9 greater than 49? No. So the answer for this question is, you can write it in two ways. A, you can write it like this, like I've written it. Or the other way of writing this is x is greater than 7 and x is less than -7. It's the exact same thing, whichever way you write it. So if I now move over to the right-hand side, it looks like I will have to use a quadratic formula because it is a calculator paper. So if I was to put this into a quadratic formula, so that's going to be something like, so 31 squared minus 4 times 5 times -72 all over 2a, which is 2 times 5. And if you type that in your calculator, you get the answer at -1.8 and 8. Oh, I should probably say or 8, so it could be one or the other. And again, you can write this as that, and you can test this on your calculator. So for example, if you put 9 into here, is this equation still true? What happens if you put 5 into here? Is this equation still greater than 0 if you put 5 in as x? So again, we can either write it like this, or we can write it as x is greater than 8, or x is less than -1.8. Now, if you look at the equations, if we go with, for example, if we just stick to this one for now, because I know the mark scheme's given this one. So if we stick with this one, if I just undo that for a second. So if we just stick with this one and this one, so you notice that it satisfies, so with this x has to be greater than 7, and with this x has to be greater than 8. So we're going to use x is greater than 8 because that will satisfy both sides of the equation. And with the negative, x is less than -1.8 or x is less than -7. We'll have to use and x is less than -7 because that will satisfy both of them. And what do I mean by satisfy? So for example, in this case on the left, any values for x such as 8, 9, 10 work, but on the left we can't do 8 because it's greater than 8. We can only do 9, 10, 11. So in order for both of them to be happy, we'll have to use that range, and that range starts after 8. So that's where these come from. And that is the last question on this paper. So as usual, I hope you found this video useful, and I'll catch you in the next one.